Okay, so in this video, I wanted to run through the new, or the newly supported, I should say, Octopus Linux Docker server container. We've had this container out for quite a while now, but it's been classed as an EAP. But with 2020.6, we will release this as a supported installation of Octopus. And so to help the support team answer any potential questions that might come up. I just want to run through some of the way it's deployed, the way it's used, some of the settings that you need to know to get the most out of it, and then we'll just summarize with some of the highlights or the things that everyone should know that are useful for supporting the new image. So the first question then is, how do you typically install the Docker image? And for most people, I think the first place to start would be using Docker Compose. This is the config here is made up of two files. So this is the compose file itself, and then you have a file called .env, and that includes all the credentials and other settings that make up the deployment. And so Compose is useful because it can orchestrate multiple containers, and the example that we've given here, and this is the Docker Hub page for Octopus server. The example we've given here spins up the database as well as Octopus itself. So this is fairly self-contained, and you can pretty much copy and paste it and get a working instance up and running. So those two files there, they represent these files here. They're copy and paste here. I have changed some of the credentials in the end file, just set up a default admin password. And done things like set up a master key here. So the first thing I want to point out is that you really want to set up the master key before you boot for the first time. So if this was blank, what Octopus would do is when the database is set up for the first time, it will generate a master key for you. But it's a little bit awkward to get this key again. It's not like where you install Octopus server in Windows and you just open up the manager and find the key. The key that's generated has to be put into this field on the second boot anyway, and that means you kind of have to either watch the logs to catch where the generated key came out of, or somehow interrogate interrogate the history of your commands or something like that. That's a bit of a muck around. So it's definitely easier to just generate this up front before you boot the container for the first time. And the easiest way to do that is just run this command here. So this is openSSL rand16, just zoom in a bit, and then it's base64 encoded. And so these the resulting string here is a valid master key. And by generating this, defining this value before you first start up, you can be sure that that every boot is going to have the correct master key, and you won't find yourself having lost that key and not being able to reuse the database that you initially created. So the way to boot Docker with Compose is just with Docker Compose up in the directory where this .env and the Docker Compose file are saved. And so what that will do first time around is download the SQL Server images and the Octopus image. So the SQL Server image is this one by default, and then the Octopus Server image is, if I scroll down, this one here. And so we've just used the tag latest in our settings here to make sure that we get the latest version of Octopus. And so once that's booted up, you will be able to access Octopus on this port here. So these ports represent the port on your local machine, and then the port on the port that inside the container that gets directed to. So this second half, these numbers here are fixed. Can't really change them, but you can change the left-hand side of these. And as you can see, because I actually quite often run Octopus natively when I'm developing it, I this port here will often be already consumed. So what I've done is just used another port here that I know won't conflict with anything, and that's the port that I'd reach into for a polling tentacle. 8080 here, it's usually free for me, so I've just mapped that same externally as internally. If you look at the database, though, we've done the same thing because I run a database locally and that port's already used. I've just used a different port here, and that ensures there's no conflict. Right, so once that's up and running, you are good to go. So this is the Octopus server running from a Linux Docker container. Now, one of the things that we did to make this easy for people to use was expose something called Docker in Docker. So one of the features that came out recently was if you look here, you can specify an image where the worker will run your steps. And this is useful for script steps where you just want to pull down a collection of tools of known versions. It's also quite important if you ever have a deployment target like Kubernetes, because this target requires kubectl, the Kubernetes command line tool, to be available, and that executable actually isn't baked into this image. So in order for the health checks for this target to work, you'd actually have to run the health checks inside a container. And because Octopus is already running in a container in this instance, we have to use what's called Docker in Docker as a way of exposing that functionality. So the way that works, it's pretty simple to set up. All you need to do is this environment variable here, disable dind. Dind stands for Docker in Docker. As long as that's set to N, Docker in Docker will be enabled. Docker in Docker requires that the container running Docker in Docker have additional privileges. And so we've set this environment variable here, or this setting, I should say, to true. And that becomes this value here in the Docker compose file. You also need to run as root. So we do give you the option of running the Docker container as Octopus. We haven't actually set up Docker in Docker to run in a rootless environment. So if you don't want to run the container as root, then you would have to set this user as Octopus. You would disable Docker in Docker by setting that to yes. And at that point, there's no real reason to have the additional privileges, so you'd set that to false. So I'll just revert all those changes there, though. And so that's one of the gotchas that I think will come up in support, is this interplay between the user that's running the Octopus executable inside the Docker container, the ability or the exposure or the enablement of Docker in Docker, and this privilege flag here, which also needs to be true for Docker in Docker to work. So that's something to keep an eye out for. The second way we expect most people to install this is through, like, on a Kubernetes cluster. So if you look in here, so I have a local test Kubernetes cluster running through Kind. Kind stands for Kubernetes in Docker. I won't go into detail here, but it is just a useful tool for developing on Kubernetes locally. And this instance of Octopus has been deployed through a Helm chart. And so to access that Helm chart, you first need to add the repo that holds the Helm chart, and that's this URL here. I've already added it, so that's fine. You do Helm repo update to allow Helm to pick up the new charts. This error is actually unrelated. This used to be the public Helm repo, and it got shut down, but that's nothing related to anything we do in this demo. And then you run a command like this. So, paste again. Just clear this right? So you run a command like this to install the Helm chart. And so what this says is we want to install the Octopus deploy Helm chart. We want to accept the various EULAs. I'm going to set the image to Octopus deploy. That just it implies the latest version here. It implies that there's I'm using the latest tag. That string there is actually just the same as that. And then this master key would be a value like this. And then then you can run that command that will deploy Octopus to the Kubernetes cluster that you have configured in your kube config file, which is here. As you can see, this one here is just pointing to a local test kind Kubernetes cluster. And then at that point, you will get the, so this is the Kubernetes, the Octopus pod running on Kubernetes. This is also the MS SQL database running on Kubernetes as well. And those are exposed by, so this service here would expose the Octopus web UI. And if you did want it, this one here exposes the SQL database as well. So that's a fairly convenient way to get Octopus up and running in a cloud environment or some sort of hosted Kubernetes infrastructure. The other way that we expect people to install the Docker image is actually as a service on a like a Linux VM. So what that looks like is, if I go to the docs here, so on our documentation page, we offer two systemd service files, and these will run both Octopus and MS SQL if you want to, as standard Linux services. So what I've done here, if we look at this file here, which is systemd system, and then Docker. So I've just copied and pasted the contents of these files in here. Again, making sure to change things like admin password and master keys. You really don't want to be using copy and paste values for those on a production system. And if we look at same sort of thing for the running the SQL Server as a systemd service. So we can see them running. If we go to status, just deploy. So that's the status of was deployed. It looks like it's not actually running anymore. Must have shut it down. And then we call that one MS SQL. So what we can do here is, I think what happened here is I didn't actually enable these services. They didn't boot at startup. What we can do is start them up though. Start Docker SQL. And so you can see, even though these are running Docker images, we interact with them as if they were just regular services, and there's nothing particularly special about them at all at that point. So now the SQL service is running. So let's run. And then we can go, and we can see that both those services have now started up. And that means I should be able to open up my web browser and log in. Right, and there we go. So that's Octopus deploy running as a systemd service that pulls down those Docker images. And so that's just a matter of copying and pasting these two unit files and then running a couple of commands to reload the daemon and then start up the individual services. You probably also want to do an enable as well, actually, just so they boot up with the system. Yeah, I'm pretty sure it's just enable. Right, so that's now enabled and that would start on a reboot. So one of the questions that we do get is, do you just have a Linux installer for the Octopus server? The answer is no. We will, it's something we like to do. It is, we do have a pitch for creating a native installer for Octopus deploy. But at this point we don't. So if you want to run Octopus on Linux, on a Linux VM, just running it, the containers as a service is the solution we have for now. Okay, so another thing to be aware of is that the way tags work in Docker. So you can see here we've used the latest tag. And so what this means is that we're running essentially the Docker container identified by this. So if we go back to Docker Hub, we have a look at the list of tags. That's this one here. But this latest tag, or the Docker image referenced by this, is constantly updated. So as you can see, this was pushed 2 days ago, and you can expect the latest, the Docker image referenced by latest to be updated quite frequently. However, once you've pulled it down once, Docker considers that you already have downloaded this image and it won't attempt to refresh it at all. So that is just something to be aware of. You may want to, in a production environment, actually reference very specific tags, because these ones won't change. These don't get updated. Any new releases of Octopus will overwrite this, but then create a new version number as well. And so if we were to say here, set the tag to that, and then 2020.5.6 came out, we would be able to update the tag, and then Docker knows that it doesn't actually have this version of the Docker image and will pull it down. But if you just reference latest, it is convenient, but you lose that. There's no actual updating or automatic updating strategy there that will ensure that just because you've said latest doesn't actually mean that you've got latest. So that's not an Octopus problem. That's a common implementation detail of Docker. And I suspect anyone who's mostly familiar with Docker would kind of understand that just because they pulled latest a week ago doesn't mean they'll get latest if it changed today. But again, just something to be aware of. All right, so now one of the things we may want to do in Docker server hosted on Linux is actually connect back out to the main operating system. So in this case, this here is the instance of the Octopus server running from the Docker Compose. And what I want to do is have that reach out to a tentacle running back on my Windows box. And so what I have here is a listing tentacle already set up with the thumbnail, the thumbprint that this particular instance of the server expects. But to get back out, or to kind of reach out of the, actually no, I'll have to recreate it because that thumbprint has changed. Just delete this. Oh no, it didn't change. I didn't need to do that. Anyway, we'll run through it from start to finish. So it's the listing tentacle. Yep. The thumbprint is that. I got confused. I was looking at the server, the tentacle thumbprint instead of the server thumbprint. All right, so we now have our our listening tentacle set up. So the question is, how do we reach out of the instance of Octopus running on Docker back out to the host? And what you can't do is run localhost. So this is how you would normally have a tentacle running side by side with the Octopus installation talk to each other, but it doesn't quite work that way in Docker. The host name you actually need to put in here is a special one called host.docker.internal. And this host name here references an IP address that represents the host operating system, which is Windows in this case, that the Docker container can call to reach out to the host. So if I go next, we should see that everything will look good. Yep, let's just save that. Do a health check. Yep, and as we can see, we've reached out of the Docker container back onto the host through this kind of magic DNS name that Docker sets up for us to allow that kind of communication. So probably the next question then is there such a thing as a tentacle Docker image? And the answer is yes. So if we look here, so this is the Octopus deploy tentacle image, and again we have the Docker images here, both for Linux and Windows. And so what we can do here is I'll just run an example to show you how this works. So I'm just going to run the Octopus deploy tentacle. And again, because there's no tag here, we assume latest. This is going to reach out to my hosted Octopus instance out on Octopus Cloud. And so this is actually going to create a worker in the Docker worker pool. So that has, yep, looks like that's gone through. So this is my hosted instance on Octopus Cloud. This is the test space, which you can see was referenced here. Space is test. If I go to infrastructure worker pools, I will see I have a Docker worker pool, and that's my Docker tentacle. I'll actually just do a health check to make sure that's running as we expect. Yep, and that looks good. So you can technically run a Linux Docker image as a tentacle target. It's probably not a whole lot of value there. Some very edge case use cases where running it as a target would make sense, but there is a lot of value in running them as workers. So we will, I expect we'll start to see this Docker container, this Docker image used quite a bit as people spin up pools of Octopus workers. All right, so that was the highlights of what I wanted to show. So I'll just run back over some of the things that I think will trip people up and things that we might see coming through support. So the first one is, generate this master key first. It's a lot easier than having Octopus generate one for you, and then you try to capture that, and then remembering to edit your config files to paste it in. If you do it up front, it's a lot easier, and you can generate a brand new random key with this command here. Actually, one thing I do want to point out here is that these the persistent data has all been placed onto a Docker volume. And so what happens in Docker is that any changes to the file system are more or less temporary. I mean, they do survive the container being started and stopped, but if you actually remove the container and recreate it, those changes are lost. unless you've actually saved any change data in a volume. And so what we've set up here is 5 volumes with these names here, and then those are mounted to these directories here: repository, artifacts, task log, cache, and import. And so what that means is that if we have to recreate this container for some reason, perhaps we actually just want to update the tag, so we'll necessarily have to get a new container out of that. That new container will reference these directories here, and the volumes will persist that data. So if you don't use volumes, there's a very good chance that you will lose data, and things like upgrades become almost impossible. So definitely make sure that that any production Octopus instance is saving the data on these directories here out to volumes. And the last one was that Docker and Docker. It's the combination of these 3 settings here: the disable dind setting, which is set as the same environment variable name. So that has to be N or left blank to enable Docker and Docker. If that is set to yes, Docker and Docker won't be booted as part of that image. If this is set to no, then the container itself needs this privileged mode, which is this setting here. Again, Docker and Docker just doesn't work without those additional privileges. So we've set that to true here. And the user. So Docker and Docker does require today that the user is set to root. If you don't, you do have the option of running the container as Octopus, but Docker and Docker won't work there. And yeah, so that's everything. We will be announcing that this Linux server Docker image at 2020.6 is officially released and officially supported. And I think there's been a few people already using it. We have announced the EAP, and it seemed to gain a little bit of traction. So I think a couple of people are using it already, but the traffic will probably go up once it's a real supported release. So if you have any questions, let me know. And otherwise, thanks for listening, and I'll see you next time.